Welcome to part 2. So let's continue on with algebra and formulas. So question 8, we have that a cubed over 2b squared times 4a squared over b to the 5. We multiply the top and multiply the bottom. So we get a cubed times 4a squared over 2b squared times b to the 5. And so that's 4a to the 5 2b to the 7. There's nothing we can do about the a's and b's, but we could cancel down the 4 and the 2 to give 2 and 1. So what we get is 2a to the 5 over b to the 7. Question 9, we want to factorize x squared minus 5x minus 6. So we want to find x plus some number times x plus some number, another one, where the sum of a and b is minus 5 and the product gives me minus 6. So with this, we get the collection that a and b must be 1 and minus 6, or 2 and minus 3, or minus 1 and 6, or minus 2 and 3. If our solutions are integers. So if it's an easy factorization. And we can see that 1 plus minus 6 does give me this. And so we have that this is x plus 1, x minus 6. And you should multiply this out and check that this is the right factorization. So for question 10, we want to solve z squared minus z minus 10 equals 0. And you could try to factorize this, but it turns out to be hard. But we're going to try the quadratic formula instead. So if I do a, b, and c, so a is 1, b is minus 1, and c is minus 10, we have that z is equal to minus b plus minus root b squared minus 4ac over 2a. I know you guys can do this, and you get that this is, when you input a, b, and c, you get that this is eventually 1 plus minus root 41 over 2. That is, z is equal to 1 plus root 41 over 2, or z is equal to 1 minus 41 over 2. So for question 11, we're going to look for simultaneous solutions of a minus 2b equals 5 over 2, and 2a plus 3b is equal to 3 over 2. And so what we're going to do is, let's call this equation 1 and this equation 2. We're going to try to eliminate a, and that gives us a solution for b. Could do the other way around, but this one's easier. So if I consider 2 times 1, so multiply equation 1 by 2 on both sides, get that 2a minus 4b is equal to 10 over 2. Now subtract this from number 2. This gives us that 2a plus 3b minus 2a minus 4b is equal to 3 over 2 minus 10 over 2. And so we get that this minus minus becomes a plus. 7b is equal to minus 7 over 2. And so b is minus a half. Let's put this back into my original equation. And what I get is that a minus 2 minus a half is equal to 5 over 2, and so a is equal to 3 over 2. Okay, we're going to move on to graphs now. And for this question we have 2 points. Firstly, we want to label the axis. There's x, there's y. And we have the points minus 2, 7 and 3 minus 3. So let's just label those. So I go minus 2 along and then 7 down. Gets that point. Let's call that A. Let's call that B. Oh, no, I've done this wrong. Look. So A is minus 2 plus 7. So it should be up here. There's my deliberate error. And B is 3 minus 3. So that's 3 along and 3 down. There's B. And we want the line between them. So it's going to look like this. And it keeps going. I'm only going to draw a little bit of the line. So here, there's also an x and y intercepts. So this one is the x-intercept because it crosses the x-axis. And there's the y-intercept, crosses the y-axis. How do we find these? Let's find the equation of the line. Y equals mx plus c, where c is the y-intercept. And we need the slope. So this is the rise over the run. So that's change in y over change in x. So we get this is minus 3 minus 7 over 3 minus minus 2. That's minus 10 over 5, so that's minus 2. Note that at least the sign is correct. We have a downward sloping line. It should be a negative slope. So we put in minus 2, 7 into this formula. What we get is that 7 equals minus 2 times minus 2 plus c, and c is equal to 7 minus 4, so that's 3. We immediately obtain that the y-intercept is 3. And if you solve when y equals 0, x is equal to 3 over 2. So there's a little bit more in this section on probability and stats, because it's the most recent one, and I thought you might need a little bit more practice. So we do question 13. A fair 5-sided dungeon dice toss, what's the probability of obtaining an odd number? So the sample space of outcomes is 1, 2, 3, 4, 5, and the probability of it being you getting an odd, well that's 1, 3, or 5, is 3 over 5. So if you toss it twice and look at the products, we can fill out the table. If I multiply these numbers, bear with me as I multiply these out. We want to find that the probability that the product of the values are even. So what do I get? We get that one, all of these because I've multiplied by 2, that one, all of these again because I multiplied by 4, and these. So there's 1, 2, 3, 4, 5, 6 plus 10, so there's 16 even numbers. So therefore the product that the probability that the product is even is 16 over, well there's 25 total options, 16 over 25. For question 14, So this is like a standard statscape problem where the first thing we should do is to reorder our data into increasing rank. So there's 10 terms. And the mean is the sum over the number of values. And so if you actually work this out, if you work out the sum, you get 50. And so it's 5 seconds. The median, because we have an even number, is the halfway point. So the average of this one and this one, when they're ranked. So there's a coincidence here in that this is the 5th term and that's the 6th term, and it's equal to 5 and 6 respectively. But that's a coincidence for this problem. So it's the value of the middle terms, not just which term it is. So if I changed the data and made those middle terms bigger or smaller, this median would change. And the mode is the easy one. That's the one that appears the most often, and that's just 6. So we were asked what is the sample standard deviation. So for the standard deviation, we need the square root of the variance. And so we take the square root of 1 over 10 minus 1. And we take the differences of our values with the mean. So it's a big long sum. As I said, you're going to take a little while to do this in the exam. Last one being 8 minus 5. And we find that it's actually equal to uh, 42 over 9 all square rooted. If you like, you could simplify this slightly. And finally, I asked for 2 plausible reasons why there's an unusually fast response time. And so just anything in words that's reasonable is fine. For instance, the sample might have been incorrectly taken. The user might be an expert games player. Think about your StarCraft 2 players. The user maybe just got lucky. And there might be simply a wide variation amongst users. Maybe the other users were slow. And so on. Thank you for listening and good luck in your exams.